Hello and welcome to this video lesson. In this video lesson we will cover the basics of factoring. This lesson is designed to teach you step-by-step method of factoring, but before starting we're actually going to review expanding. So the first example here says expand the following, and we have 5 times this binomial here. Is a binomial because it has two terms of 4x and 3 separated by a plus sign here. And to expand, we have to use the distributive property and distribute the 5 to the inside the brackets. And by expanding, we remove the brackets and it becomes 5 times 4x plus 5 times 3, which ends up being 5 times 4, 20, x, and 5 times 3, which is 15. In the second example, we're going to do the exact same thing. We're going to distribute what's outside of the brackets into the brackets, and we get 5x squared y times 4x plus 5x squared y times 3. And to simplify it, we get 5 times 4 here, 20, x squared times x here, which gives us x cubed, and y is the only variable here, so it's pretty much y times 1, which is just y. So again, 5 times 4 gives us 20, x squared times x gives us x cubed, and we're left with y. And then on the other hand, we have 5 times 3, which is 15, and x squared y stay as they are because they're pretty much being multiplied by 1. So this whole procedure of expanding means to distribute something into the brackets, and by expanding we remove these brackets in our final answers. Now it is actually important to be able to do the exact opposite of expanding. So meaning if I have a term or an expression like this or this, I should be able to bring it back to its factored form, which is 5 times 4x plus 3. So we're bringing back the brackets, kind of. So factoring is the reverse process of expanding. That's the best definition. And to look at it here, if we have 5 times 4x plus 3, which is what we had here, to expand it, we get 20x plus 15. But to factor it, we go back from 20x plus 15 into 5 times 4x plus 3. Now, to fully factor something, the first step is to find the greatest common factor. And the greatest common factor is the greatest factor that divides those terms. So let's find the greatest common factor for the following. So for the first ones here, I have 4 and I have 6, and I'm trying to find the greatest common factor. So the factors of 4 are 1, 2, and 4. And the factors of 6 are 1, 2, 3, and 6. Because 4 can be divided by 1, it can be divided by 2 to get 2, and it can be divided by 4 to get a whole number, which is 1. 6 can be divided by 1 to give us 6, 6 can be divided by 2 to give us 3, 6 can be divided by 3 to give us 2, and 6 can be divided by 6 to give us 1. So now, looking at the greatest common factor, we can see that the only common factor that we have is, well, we have 1 and we have 2, and the greatest common factor in this case is just a value, and this value is just 2. For 12 and 13, we will do 30, we will do the exact same thing. For 12, we get the factors 1, 2, 3, 4, 6, and 12. And factors of 30 are 1, 2, 3, 5, 6, 10, 15, and 30. So the common factor between these values are 1, 2, 3, 6, and that's it. And the greatest common factor between them, or the largest value between them, is a 6. So now for the next example here, not only we have a value or numbers, we also have variables. So let's do it like this. We're going to separate the numbers. So we're going to have 4 and 2. And we're going to separate the variables, x3, x cubed, and x. So for the values, my factors are 1, 2, and 4. And for 2, 1 and 2. For x cubed, I'm just going to write it out. It's multiplication of x, x, and x. And for x, it's just 1x. So my common factors are 1, 2 for the values or for the constants. And for my variable, it's just x. So my final greatest common factor will be 2, because 2 is the greatest common factor here, and x, because x is the greatest common factor for my variables. You can see that these two x's here don't really contribute to my final greatest common factor. So one way, just looking at the variable, and this will become more apparent when we do this example, is look at your variables. In this case, x variable is both for x cubed term and the 2x term. So x will definitely be here, and in terms of exponents, the greatest common factor will have the least exponents of x. So here my exponent of x is 3, here the exponent of x is 1, and the least exponent value is 1, so that's why I have 2 to the x as my greatest, 2x as my greatest common factor. We are going to do the exact same procedure for this one. I'm going to have 18 and 12, and I am going to have x, 4, y, z, and x cubed, y cubed here. So for 18, my factors are 1, 2, 3, 6, 9, and 18. And for 12, it is 1, 2, 3, 4, 6, and 12. For this one, I'm just going to expand it. X times x times x times x gives me x to the 4, y and z, and x times x times x gives me x cubed, y times y times y gives me y cubed, and I don't have a z there. For my greatest common factor, first I have to find all the common factors. So I have 1, 2, 3 as my common factors. I actually have 6 here. And for my variables, I have 1x, 2x, 3x's, and I have 1y, which is shared between the two terms. So to get my greatest common factor, the greatest common factor within my constants it's just 6, and for my variables, it is x times x times x, which is x cubed, and y. Note that if you want to kind of take a shortcut and not write everything down, First of all, it takes a little bit of practice to figure out greatest common factor between constant values, and once you get good at it, you can easily look at 18 and 12 and right away pick 6. But if you are having trouble with that, just draw this out, write out all the factors, and see what the common ones are and pick the greatest common factor there. For the variables, you can either write it out, but if you don't want to write it out, just look at the variables that are shared first. So in this case, my x variable is shared, my y variable is shared because they both have y, they both have x, but there's no z value or there's no z value in both of these, so z will not be here. So in terms of exponents, this one has an exponent of 4, so x has an exponent of 4 attached to it. X here has an exponent of 3 attached to it. The least exponent is 3, so that's where the 3 goes here. And between y and y cubed, I have exponent 1 for y here. I have exponent 3 for y here. And the least exponent is, or the least value of exponent is just 1, and therefore y is my variable here. So my greatest common factor ends up being 6x cubed y. So in this example, we will look at how we can divide polynomials. So in the first example here, I have this term being multiplied by this whole trinomial because I have 1 term, 2 term, 3 terms, which makes it a trinomial, and I am going to have to distribute the term outside of the brackets into the bracket. So once I do that, I'm just going to write everything down. I get 9x squared, which is on my numerator because I can treat this as 9x squared over 1, this as over 1, and this as over 1. And I will get 9x squared times 1, which is my numerator, and my denominator will be 3x squared times 1, and that would go in my denominator. So I will get 9x squared over 3x squared plus, then I am multiplying 6x cubed yz by 1 over 3x squared. So the numerators multiply, the denominators multiply. Anything multiplied by 1 is itself, so I get 6x cubed yz over 3x squared. And finally, I get 3x to the 8 over 3x squared, because my numerator, 3x 8 times 1 is 3x to the 8, and 1 times 3x squared gives me 3x squared as my denominator. Now to simplify, 9 divided by 3 gives me 3. And in terms of variables, in the first term, x squared divided by x squared is just 1. It just cancels out because any number divided by itself is 1. And I'm left with 3 for my first term, plus 6 divided by 3 gives me 2. X cubed divided by x squared will give me x. And to see how I got that, you can think of it this way. X squared over x squared is equal to, they have the same base, so we keep the base, but we subtract the exponents, and I get x to the 1, or just x. And I am not dividing y or z by any other y and z, so I'm left with 2x y z for my second term. Lastly, for my last term, the 3 divided by 3 gives me 1, so I don't have to write anything there. X to the 8 divided by x squared, they have the same base, which is x, so I have to subtract their exponents, and 8 minus 2 gives me 6, so I'm left with x to the 6. So now the reason I put this one down is just to show you that this and this are the exact same way of writing the same expression. So in this case, I have 9x squared plus 6x cubed yz minus 3x cubed, all divided by 3x squared. And this is pretty much the same thing as this, meaning that my first term needs to be divided by 3x squared, and I have to add that to my second term divided by 3x squared, and I have to subtract that by 3x to the 8th divided by 3x squared. Now, sometimes students get that confused, so I just want to write an example here. If we had 3 over x plus 4 over x, I would write that as common denominator of x and 3 plus 4 on top, because my common denominator is x, and if we have the same common denominator, we can just add the numerators. So then 3 plus 4 over x is same as saying 3 divided by x, which is this term over here, plus 4 divided by x, which is this term over here. So again, this will mean that I have 9x squared divided by 3x squared, same as how this turned into this, plus 6x cubed yz divided by 3x squared, similar to how this turned into, or this turned into this, or this turned into this, and subtract that by the last term divided by 3x squared. So if I have a whole polynomial being divided by anything, that means each term is being divided by that term. So to write this out, I get 9x squared divided by 3x squared plus 6x cubed yz over 3x squared minus 3x8 divided by 3x squared. And once again, this divided by this divided by this, and this divided by this. And we can see that they have the same common denominator, so I can just put this all under one fraction and then add everything on top. You can see that this is equivalent to this, so meaning that this whole expression is equivalent to this expression over here. So my final answer will be 3 plus 2x yz minus x to the 6. Okay, time to do some practice. Why don't you folks pause the video, try out these 3 examples, this, and this, and once you're done, play it back and check your solutions. Okay, for the first example that we have here, I'm going to divide it into pieces. So I'm going to do 3m squared n divided by 3n minus 6n divided by 3n. And once I have this, I can start to simplify. 3 divided by 3 is 1. M squared is not being divided by anything, so I have to keep it. And n cancels out with n, and I'm left with m squared minus 6 divided by 3 is 2. N divided by n is 1, and 2 times 1 is 2. For a question like this, you have to show your final solution and an optional check mark here to show your steps. For this question over here, I'm going to break it down. 3x squared y cubed over 10x squared minus 20x squared z squared 10x squared plus 50x squared over 10x squared. I'm going to start simplifying. 30 divided by 10 is 3. X squared cancels out with x squared, making it 1. And y cubed isn't being divided by anything, so I'm left with 3y cubed minus 20 divided by 10 is 2. X squared cancels out with x squared, and I'm left with 2z squared here, plus 50 and 10 cancel out, and I get 5, so 50 divided by 10 is 5, and the x squares cancel out, I'm left with 5. In terms of steps, the final answer for accuracy and optional for method, it will be very important to actually show this, or actually show some ways that you're canceling things out. But once you get very comfortable with these type of questions, you can easily just go from here to here without the intermediate step. For the last question over here, I have LW minus LWY divided by LW. Using BEDMAS, the first thing that I have to do is brackets, but inside brackets I can't really simplify, so I can just get rid of the brackets. So I will have LW minus LWY over LW. And once I have this, I can divide it, I can break this down. I will have LW over LW minus LWY over LW. So let's write that out. I get LW over LW minus LWY over LW. And what will end up happening is that these cancel out, and I'm left with 1 minus, and LW and LW cancel out here, and I'm left with Y. Now, the most common mistake when it comes to a question like this is once students see this, LW over LW, many of them say, well, they're canceling out, so there should be nothing here. So they just leave their final answer as negative Y. So note that LW over LW is equal to 1, because any number divided by itself is equal to 1. So, and it does not equal to 0. Whereas LW minus LW means you're subtracting an orange from an orange, and you get 0, you will have nothing. And this does not equal to 1. So pay really close attention to this. When you're dividing something by itself is always equal to 1. And when you subtract something by itself is equal to 0. In terms of check marks, 1 check mark for here and 1 for the optional steps. So by now we have learned how to find the greatest common factor. We've also learned how to divide a polynomial by a term. So we're going to combine the two in order to find out how to factor a polynomial. So once the greatest common factor is found, the second step is to divide the expression by the greatest common factor. So let's do the first example here together. I have 4x plus 8, and I want to find the greatest common factor first. I can break it down. Let's do that on the side here. 4 and 8. 1, 2, 4. 1, 2, 4, 8. So you can see that the greatest common factor is the 4 for my constant, and I have x in this term, but I don't have the x in this term, so x will not be part of my greatest common factor. So 4 is my greatest common factor, and the next step would be to divide every term by my greatest common factor and put it inside the brackets. So I have 2 terms here, so I will have 2 spots inside my brackets because it's a binomial. So 4x divided by 4, so 4x divided by 4, the 4's will cancel out, and I'm left with x. And 8 divided by 4 gives me 2. So to write that out, here, this is 4x divided by 4, and this one is 8 divided by 2. And my final factored form is 4 times brackets x plus 2. Let's do a few other examples. So we got 4x cubed plus 2x squared. To find the greatest common factor, I'll write that out here. I can write it like this as well, so you can see another way of writing the same thing. I have 1, 2, 4. I have 1, 2. I have x, 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 and I have x, x. So my greatest common factor is 2, because between the constants my greatest common factor is 2, and x squared, because I have x times x as my greatest common factor for the variables. So now looking at this again, 4 and 2, I get my constant of 2, and these two both have the x term, so I leave the x, and the lowest exponent is 2, so that's where I get the 2 from. So now 4x cubed divided by 2x squared, I will write that out here, 4x cubed over 2x squared, and this one is 2x squared over 2x squared. So for the first one over here, 4 and 2 cancel out to 2, x cubed and x squared. I have 3 x's on top, 2 x's in the bottom, so 2 of the x's cancel out, and I'm left with 1x. So I get 2x here, and 2x squared over 2x squared does not equal to 0, but does equal to 1. So I get 1 over here. So my final factor form is 2x squared times 2x plus 1 within brackets. For the next question, we're going to follow the same steps. 18 and 12, we had found the greatest common factor between those values before. It was 6. X cubed and x, both terms have the x, so I'm going to leave the x in here. The lowest exponents between them, this one has an exponent of 3, this one has exponent of 1, so the lowest one is x. And both of them share the y, and the lowest exponent between the two terms having the variable y, or the exponent of y between the two terms, is just 1. So now here I have 18x cubed y over 6xy, and here I have 12xy over 6xy. 18 divided by 6 is 3, x cubed divided by x is x squared, and y's cancel out. 12 divided by 6 is 2, and xy and xy cancels out to give me 1, and 2 times 1 is just 2 here, and 3x squared here. Let's try some other examples here. Here I have 15x squared plus y plus 10xy. So let's set it up first. We're going to have the greatest common factor first. So equals. My greatest common factor between 10 and 15 is 5. And variable x is shared between the two, and the lowest exponent of x within the two terms are just 1. So we got x, and I have y in both, and the lowest exponent of y between the two terms is 1. I then open my brackets, and I will have two values in there. The first one is going to be 15x squared y divided by my greatest common factor, which is 5xy, and the second one is going to be 10xy over my greatest common factor, which is 5xy. 15 and 5 gives me 3. X squared divided by x gives me x, and the y's cancel. 10 divided by 5 gives me 2, and the xy's cancel. So I'm left with 3x plus 2 as my final answer. For the next one, to find my greatest common factor, I have to look at values of 3, 9, and 12. 3, 9, and 12. And the greatest common factor between those three is just 3 once you write it out. So I get 3. For my variables, I have x cubed, x squared, and x in all of my terms. So I will need an x here. And my lowest exponent, I have exponent of 3, 2, and 1. So my lowest exponent is just 1, so I'll leave that as x. I have y in this term. I don't have a y in this term, and I do have y in this term. But because I don't have it in here, it can't be a common factor anymore because it's not common between all three terms. So I can't write a y here, and I don't have a z here or here. So really, I can't put the z here either. So therefore, my greatest common factor is 3x. And to find each term, I will first divide 3x cubed yz by 3x, and then 9x squared by 3x, and then 12xy by 3x. So let's write that out here. 3x cubed yz divided by 3x. And then I have 9x squared 3x, and I have 12xy over 3x. So first, 3's cancel out. X cubed over x is x squared because they have the same base, and I'm subtracting their exponents of 3 and 1, and 3 minus 1 gives me 2. And yz just stays, so I'm left with x squared yz plus 9 divided by 3 is 3. X squared divided by x is x. So I get 3x. 12 divided by 3 is 4. X divided by x is 1. And I'm left with 4y. Okay, why don't you folks now take some time, pause the video, try out these questions on your own, and once you're done, you can play the video and check your solutions. Alright, for the first expression here, I have 15abc minus 5b. The greatest common factor between 15 and 5 is just 5, and the a variable is not shared, b is, but c isn't. So the only thing that I can write in here is b. And in terms of exponents, I have exponent 1, so I'll leave this as exponent 1. Now 15abc over 5b, 15 divided by 5 is 3. A is not being divided by any a variable, so I keep it. B divided by b is 1, so it cancels out. And c divided by 1 is c, so I'll keep it here. And then minus 5b divided by 5b. I'm dividing 5b by itself, so I should get 1. And that should be my solution. So this can be done in one step. You can show your steps of how you divide it. So you can show that 15abc over 5b and 5b over 5b, and that this is equal to, and you can start canceling these out to show that you understand what goes in here for an optional check mark. For the next example, my greatest common factors between 4, 6, and 8 should be 2. All of them have x, and the lowest exponent of x here is 3, 2, and 1, so it'll just be 1. And then one other way of writing it, so I will write it like this so that you can see 4x cubed over 2x plus 6x squared over 2x. So I'm dividing all my terms by my greatest common factor. So then I get 2x, 4 divided by 2 is 2, x cubed divided by x is x squared, 6 divided by 2 is 3, x squared divided by x is x, 8 divided by 2 is 4, and x cancel out. So I'm left with 2x squared plus 3x minus 4. So optional and a full check mark for the final factor form. Now for the next example, my greatest common factor between 12, 4, and 8 is 4. All of the terms have x in them, and so this one has x, x, and x. And my lowest exponents between 3, 2, and 3 is the 2, so I will keep that here. All of my terms have y, so I will keep that in. And my lowest exponent between 4, 2, and 5 is 2, so I will keep that in. Open my brackets. And again, I'll go over the long way so you folks can see what's actually happening. 12x cubed y4 divided by my greatest common factor minus 4x squared y squared divided by my greatest common factor plus 8x cubed y to the 5 divided by my greatest common factor. Cancels out to 3, cancels out to x, cancels out to y to the 2. And again, here I have the same base, which is y, and I have to subtract the exponents. 4 minus 2 gives me 2. 4 divided by 4, x squared divided by x squared, and y squared divided by y squared. And again, this does not equal to 0, it does equal to 1. And these two cancel out to 2. X cubed divided by x squared is x, and y to the 5 divided by y squared, same base. You have to subtract the exponents, and 5 minus 2 gives us 3. So my final solution will be 4x squared y squared 3xy squared minus 1 plus 2xy cubed. And again, common mistake is when students write 4x squared y squared 3xy squared, but they say there is nothing here, or they say that there is this term divides itself out and you get 0, and they just write 2xy cubed. So this is not the solution, since 4x squared y squared over 4x squared y squared is any number divided by itself, and that is simply equal to 1. So check mark here and an optional check mark here. Okay, last practice question on this page is this one over here. So the greatest common factor between 3, 9, and 18 will give you 3. For my variables, I have g in all of them, and my lowest exponent is 4. So I get g to the 4. And I have k in all of them, and my lowest common, or my lowest exponent is 4. I get 4, 4, and 5, so 4 would be the 1, so k to the 4. And then, so I don't have to write this step down, so for the last one, I will just show you how to do it without writing it down. I have 3g4k to the 4, so 3's and 3's cancel out, g4 and g4 cancel out, and k4 and k4's cancel out. So I'm left with 1 minus, and then 9 divided by 3 is 3. G to the 5 and g to the 4, when you divide them, they have the same base. Their exponents needs to be subtracted. So 5 minus 4 will give me an exponent of 1. So I'm left with 3g to the 1, or just g, and k to the 4 and k to the 4, when they divide out, they're the same number. Dividing by itself just means 1, so I don't have to write it out. Plus 18 divided by 3, so 18 divided by 3 will give me 6. G to the 4 divided by g to the 4, same thing divided by same thing, will give me 1. And k to the 5 divided by k to the 4 will give me k to the 1. So I'm left with 6k as my final answer here. One of the applications of factoring is to rearrange formulas, and so far when we've been rearranging formulas, we've always had just x on the left-hand side, and everything else on the right-hand side. But sometimes you will get a little bit more tricky situation where in this case you have x, y, and 4x, and you can't really simplify them because they're not like terms. So here's what you should do. You should move everything that has the variable that you're looking for. So in this case, we're trying to isolate for x. So move all the terms that have the variable x to one side of the equation. So move all terms with the unknown variable, or the variable that you're looking for, to one side of the equation, and everything else to the other side. So let's do that for this situation over here. First, I want to move the 4x here to this side, so I will subtract 4x from both sides. And I want to get rid of the 3 on the left-hand side because it doesn't have the x variable. So I will subtract 3 on both sides as well. So this cancels out the 4x, this will cancel out the 3, and I will end up getting x, y minus 4x is equal to negative 3. I now have all my all my terms that have the x on the left-hand side, and everything else on the right-hand side. So that's good, but I can't simplify my term here, or my expression on the left-hand side. So what I will do instead to isolate for x is I will factor out just the variable that I'm looking for. So here, second step is to factor out your variable. So if I factor out an x, that means I have to divide, and I will do it with complete steps here, xy by my whatever I'm factoring here, which is x, and I have to do 4x divided by x as well, and that is equal to -3. So what I've done is I've taken out x, which is what I'm trying to isolate, and I factored it out. So if I factor it out, it will not be present here after I simplify this binomial. So let's simplify it and see what happens. So x's cancel, and I'm left with x y minus 4 is equal to -3. So now that's convenient because once I have factored it out, I can just divide both sides by y minus 4, and that would simply get rid of the y minus 4 on the left hand side, and I'm left with x is equal to -3 y minus 4. So last step is to divide out to isolate your variable. Now there is other forms of writing the same solution. So if you have done it differently, for example, if you had originally moved the xy to the right hand side and kept the 3 as +3, your final answer would actually equal to 3 4 minus y. And these two are pretty much the exact same thing, and the reason for it is, I'll write it out here, -3 y minus 4 is equal to 3. You can bring the negative to the denominator, and then you can distribute the negative to the both terms, and you get 3 -y plus 4, which is equal to 3 4 minus y. And it doesn't matter which way you write your final solution, they mean the exact same thing, but just expressed in a different way. Alright, why don't you pause the video, try out this question on your own, so you're trying to isolate for x, and once you're done, you can proceed with the video and check your solution. So to do this question, the first step is to move my terms that have the variable that I'm looking for to one side of the equation. So here I have the 3x on the right hand side, and I have another x on the left hand side. So let's move everything to everything that has the x to the left hand side. This one doesn't have the x in there, so I'll just keep it in the right. So plus 3x plus 3x, that will cancel out this term, and I'm left with 4wyx plus 3x is equal to 5. My next step is to factor out my x, or the variable that I'm trying to isolate. So if I do factor that out, I get x here, and 4wyx divided by x, only the x's cancel out, and I'm left with 4wy plus, and then I have 3x divided by x, which gives me 3 is equal to 5. And for my final step, all I need to do is divide both sides by 4wy plus 3. And this cancels out with this, and I'm left with x is equal to 5 divided by 4wy plus 3, or 3 plus 4wy. In terms of showing your steps for this, one for accuracy mark, and in terms of method, you need to show at least one step. So I will put another mandatory check mark there for your methodology there.